Okay. All right, did you have any question on your homework? Do you have any question on your homework or anything? Okay, let's finish some of the. Let's go through what we did. So we can do an example on section 8.5. So let's look at one example on section 8.5. Now, so we say if we can still recall this. Here so that you can always remember. So if we have, let's say 1 all over the square root of, let's say, p there. Oh, and we want to rationalize the denominator. Then we need to make sure that the denominator actually here doesn't have a what? A radical. It doesn't have a radical. Now, since this one is equals to 1 all over p raised to 1 over 2. I don't know whether guys in Zoom can see this. If 1 over 2 equals to p, then since we want to make this one not to have the radical, then we need to multiply by what? The value, which will do what? We should remove the radical here. So what you do on the denominator, you do it on the numerator. So in this case, what will remove this 1 over 2 here? P what? 1 over 2, right? Since when you add the 2 of them, you get what? Since the base are P and P, so it is actually P 1 over 2 multiplied by P 1 over 2. Using the properties in 5.1, then this is similar to P 1 over 2 plus what? 1 over 2, right? And this one is equals to P raised to 1. Raised to 1. Since 1 over 2 plus 1 over 2 is half plus half, you get what? 1. You get 1. So what you do here, you do it over here, P 1 over 2. Now, similar to canceling this one, and you still get the same thing here, because this and that will be 1. It is similar to canceling that and that, you get 1. So finally, this will be P 1 over 2 all over what? This is the same as the square root of P. The square root of P. Now, if you have, let's say 1 all over P, the cube root of that. The cube root of that. So what will you do to remove that radical down there? So this is similar to 1 all over p raised to what? 1, right? 1 all over p raised to 1 all over 3. Now, to remove this radical here, then you do what? P raised to what? 2 over 3. So what you do here, you do it over here. P. When you multiply this and this, then it is the same as adding the powers here. So 1 over 3 plus 2 over 3 is what? Is 1. So finally, this is the same as p 2 all over 3 all over what? Now, this is in exponent form. How can we write this one in a radical form? So it is equals to the cube root of what? P squared. The cube root of p squared. So please try to remember how we do it. Remember how we do that. Okay, for example, so we did an example here, which is said, let's say we have 3 all over. Doesn't equal. Now, let's say we have 3 all over, and I think we did this, the cube root of 15 cube. The cube root of 15 cube. And then we are told to simplify. Simplify that. So to simplify that, then we need to remove the what? So it is similar to, so this is actually similar to what? 3 all over what? 15 q raised to 1 over 3, right? 1 over 3. Now, to remove the radical, then what happens here? We do what here? 2 all over 3. What you do down here, you do it up here. 15 q raised to 2 all over 3. And finally, what do you get? 3, 15 q raised to 2 all over 3. All over what? 15 what? Are we together? Since 15q, since the bases are the same, 15q is the base and this one is the same, then 1 over 3 plus 2 over 3 is what? It's 1. So finally, here is 15q there. So in terms of radical, how can we write the above? So this is equals to what? 3, the cube root of 15q square all over. To simplify this, that and that can be equals to what? The cube root of 15q square all over. So that is how you simplify. That's how we simplify. Any question? Okay. I know it's very easy when you do it in class, but when you guys are left alone, get lost, right? So you practice, you need to practice. You need to practice. And then make sure you see how I'm putting them in steps here. Try to do them like that. Make it to be so clear. Like do it stepwise. If you do it stepwise, you'll not make any error. Okay, another example. Again, we can still write this as actually you can still write this as the cube roots of 15 cube, and then we square the all of it equals 5. It is similar. It is actually similar. So we can bring the square outside. So it is actually similar to that. I know Newton can be so crazy at some point. Might not accept some of the things. So you can try this. If it doesn't do this, then it is similar to getting the cube root inside here and then the square all of that. Okay. But in your exam, you can put it in any way that you want, as long as it's a correct thing. As long as it's very correct. Okay. Now, let's simplify this square root of 7 all over the square root of q plus the square root of 13 by rationalizing the denominator. By rationalizing the denominator. So how will you rationalize the denominator? Now, if we have, let's say, we call, if we have, let's say, 1 all over the root of a plus the root of b, call that. Then to rationalize the denominator, then in this case, we multiply by what? The negative of this, the root of a minus the root of b. What you do down here, you do it up here, the root of a minus the root of a minus the root. So it is similar to just canceling that and you get that one. Now, when you come and multiply the two of them here, this root of a plus the root of b, root of a minus the root of b is similar to what? It is similar to what? A minus b, a plus b is the same as, right? Right? This is a difference of squares. It's a difference of squares. So it is similar thing to this. So this is actually the same as a minus the root of b all over the root of a square minus the root of b square. The root of a square minus the root of b square. And what is the root of a square? That is a raised to 1 over 2. When you square it, you get what? A, right? B raised to 1 over 2. When you square it, you get. So finally, this is equals to the root of a minus the root of b all over a minus. Now, coming back to this example here, then we do the same thing. So coming back to that, then the root of 7 all over the root of q plus the root of 13, we multiply by the conjugate of this one, the root of 7 of q minus the root of 13 all over the root of q minus the root of 13. Using the same analogy that we used up here, then this is equals to the root of 7 multiplied by the root of q plus the root of 13 all over 1. Difference of squares here. It means this one will be equals to q minus 1. That is how we rationalize. That's how we rationalize. Any question? Any question after that? Now, if we have, let's do the last example in this section. If you're given the root of 38 minus the root of d all over the root of 38 plus the root of, rationalize the denominator. Rationalize the denominator. So what did you get? So how will you rationalize the denominator? So the root of 38 minus the root of d all over the root of 38 plus the root of d will multiply by the conjugate of the what denominator, which is the root of 38 minus the root of d all over the root of 38 minus the root of, and finally this is equals to the root of 38 minus the root of d, the root of 38 minus the root of d all over 1. 38 minus 1. 8 minus. Now, since these are the same, the two of them are the same, then it is similar to the root of 38 minus the root of d square all over 8 minus d. 8 minus d. Any question up to that? Are we okay? All right. Now let's come now to the next section, which is section 8.6. 8. Now we need to solve now the radical equation. Section 8.6. Solve a radical equation. So the radical equation. So how will we now this is a radical expression. When we put the equal sign, then it becomes the radical equation. So an equation in which a variable is in radical of a radical expression is called radical. So equation in which is the radical of the radical expression is called the radical equation. Radical equation. Now, how can we solve the radical equation? So just the way we've done all those equations. So since we have here, in this case, let's say we have the square root of a to be equals to 1. Then here, we need to know how we can solve this. How can we solve this one? So here, what you do first, you make sure that the radical is on one side and the other values are on the other side. So you actually set the radicals to the other side and then you set the other ones to the other side. So you make sure that the radical is on the other side. So to solve this, then this is actually similar to a raised to 1/2 equals to what? Equals to. Now, what you do here, we actually need to get the values of A. So to get the values of A here, then what do you do here? We multiply by the what? The square, right? So you need to square this. So what you do on this side, you do it on the other side. So our A would be equals to what? 1 square, which is equals to what? It's equals to 1 square, which is equals to. Now, if we had A to be equals to negative, is there a solution there? Is there a solution there? Is there a solution? Do we have a square root which is giving us a negative? No, right? So in that case, there is no solution there. So you cannot get a solution. You cannot say the square root of, let's say, 2 is negative 2. Square root of 4 is, the square root of 4 is negative 2 like that. No. The square roots can be equals to plus or minus, but it cannot be just the minus there. So in Newton, if you find something like that, then that means that there is no solution. There is no solution. Okay. Now let's see how we can solve some of the examples. So let's look at example number 1. So n plus 3 raised to 1/4 equals to 3. N plus 3 raised to 1/4 equals to 3. So that is actually similar to the 4th root of 1. If this one was negative here, then there would be no solution. Since this is actually even. If it was odd, then and this one is negative, then there could be a solution. But since we said, we actually said, if let's say we have n here, of A raised to n, it is similar to absolute value of A if n is what? It's even, right? N is even. And the A raised to n is equals to A if n is odd. If n is odd. Now here, that means this A is what? Plus or minus. Here, since this one is odd, then this A can also be negative here. So it can also be negative there. So what we get here is what? Minus. What we get is a minus. It can be plus, and what you get is a plus. But if it is even, then what you need to do is we take the absolute value. And the absolute value is actually the positive of that. Now, if A raised to n of an is equals to negative A, and n is even, then that means there is no solution. There is no solution here. There is no solution. There is actually no solution. If this n is even, then there is no solution. But if it is odd, then it doesn't have an issue, because if we remember some of the examples that we did, that let's say that 5th root of something like, was it 625 or let's say 625 negative there. We can still get the negative. We can still get the negative. Since this one is what? Since this one is odd. Since it is odd. So in real sense, what I'm saying is, if n is even, then you are not getting that even root to be the negative. But if it is odd, then it can still be negative. So for example, let's do this example here. Now, this is actually similar to the fourth root of what? N plus what? 3 equals to the fourth root of n plus 3 equals to 3. Now, since this is positive, then that means there is what? There is a solution here. But if this is even and there is a negative here, then what you do, there will be no solution. So there will be no solution. Now, since this one is even and there is a negative, positive here, then it means there is a solution. Then we need to solve from there. But if there was a negative here and this one is even, then you don't have to solve. You just put there one. No solution. Now, here, this is n raised to 3, 1 over 4, which is equals to 3. Now, we need to get the value of n. Now, to get the value of n, then what do we do to the radical here? We do what? To remove this radical here, we multiply by 4. So what you do here, you raise this one by what? So what you do on the one side, you do it on the other side. Now, since this one will cancel, then we remain with n plus 3 to be equals to 3 raised to 1. Raised to 4. So what is 3 raised to 4? 81. 81. So n plus 3 equals to 81. What is our n? N equals to what? 78. N equals to 78. So you need to go back and check whether you're actually getting the right thing. So when you put it back, 78 there, so 78 plus 3 raised to 1 over 4, is it giving us 3? Is it giving us 3? So 78 plus 3 is what? 81, right? Raised to 1 over 4. Is it giving us 3? So, and this one is 3 raised to 4. And then when you raise to 1 over 4, will you get 3? Yes. So it is correct. So our n is what? N is 78. Any question? Okay, now let's do another example. 2z minus 12 raised to 1 over 3 equals to minus 12. Equals to minus 12. Equals to minus 12. Is there a solution there? Is there a solution? Is there a solution? Yes, right? Because the root there is what? Odd. The root there is odd. So that means there is a solution. So 2z minus 12 raised to 1 over 3 equals to minus 12. So what to remove this radical here, we do what? We cube there. And then we also multiply. So what you do on one side, you do it on the other side. So 2z minus 12 equals to minus 12
cube, which is equals to okay, let's reduce this. I actually reduced this one to -2. So let's just reduce it to -2. So let's not put here, let's put to be equals to -2. And also here -2 raised to 3. And this is -2 raised to 3. This will give us what? Negative what? Negative 8. -2 multiplied by -2 multiplied by -2. So this is -4. This is +4 multiplied by -2. You get -8. You get -8. Now, 2z minus 12 equals to -8 equals to -8. So you take this 12 to the other side, 2z equals to -8 plus 12, and this one is giving us 4. So z equals to 2. Z equals to 2. Z equals to 2. Any question after that? Now, now if we have the fourth root of x minus 4 plus 7 equals to, let's say, 5.
That's 4.
Yeah, x raised to 4, x minus 4 plus 7 equals to 5. So I say what you need to do before you solve the radical, then you make sure the radical is on one side and the other one is up on the other side. What do you do? Yeah, you take this 7 to second. So when you take 7, the other side, then it will be x minus 4 equals to 5 minus what?
That would be no solution.
What's that?
Wouldn't that be no solution?
Yeah, so the fourth root of x minus 4 equals minus what? -2. And this one does not have the solution. So it does not have the solution. Since this one is what? So it doesn't have the solution. Okay. Any questions? Now, if you are given another example here like this, minus 26a plus 12 plus a equals to 6 plus a equals to 6. The square root of minus 26a plus 12 plus a equals to 6. So that. So what you need to do, you take what? A to the other side. So the square root of minus 26a plus 12 equals to 6 minus 1. That's a. 6 minus a. Then you do what? You remove this radical here. So it's the same as 26a plus 12 raised to 1. 1 over 2 equals to 6 minus a. Equals to 6 minus a. So to remove this square root here, we square. So minus 26a plus 12 equals to minus 6 minus a. We do what? We square the whole of it. You square the whole of it. And some of you make some mistakes. So if we say 6 minus a square, it doesn't mean this is the same as 6 square minus a square. This is not equal to. Okay, it is not equal to that. All right. So this is not equal to this. So what you need to do, this is the same as 6 minus a, 6 minus a, right? Which is similar to 6 minus a minus a, 6 minus a. Oh, if we still remember, a minus b square is equals to a square minus 2ab minus what? Plus what? B square. This is the formula which we had. That is the formula which we have. A plus b square is equals to a square plus 2ab plus what? So those are perfect squares. Those are perfect squares. So it is similar thing to this. So this is actually the same as A, and this is the same as B. So in this case, this is like 6 squared minus 2A, which is 6, B, which is A, plus A squared. Is the same as 6 squared minus what? So A plus A squared plus A squared. So you should remember how you can actually solve it so easily without using all this long root here. So you need to remember the two formulas here for perfect squares. Perfect squares. Now here, this is now equals to what? 36 minus 12a plus what? A squared. A squared. Now, you now collect the like terms. So you now collect the like terms. So you can take all these values to the other side. So actually you can rearrange it. You can rearrange this one. So a square minus 12a, bring 26 to the other side, you get what? Plus 26a. Bring the 12 to the other side, which is plus 36 minus 12 equals to what? Equals to 0. I just rearranged it, and I took all these to the other side. So it is a square, which is this. And then minus 12a is this one, and then I take 26a to the other side, which will be minus 26a. 36 is this. I took this 12 to the other side, becomes minus 12 equals to 0. So our a square minus what? So it will now be plus what? Plus 14a. 36 minus 12 is plus what? 24 equals to. Then you need to solve the values of a. Now, in this case, is this a perfect square? Is it a perfect square? It is not, right? Because you cannot get the square root of 24. You use now the AC. Use the AC. The product is 24, and the sum is 14. What are the two numbers? What are the two numbers? 12 and 2, right? So a square plus 12a plus 2a plus 24 equals to 0. So a plus 12 plus 2a plus 12 equals to 0. Zero product property. A plus 2, a plus 12 equals to. A equals to 2 minus 2, or a equals to minus 2. So we have those two values there. Now we need to check which one will give us the correct answer in that case. So which one of these solutions here will satisfy this? So which one will satisfy minus 26a plus 12 plus a equals to 6? Now, if we start from minus 2 here, if we start from minus 2, so minus 26 times minus 2 is what? So this is the same as 51. 52 plus 12 minus 2. Is it equals to 6? Is it equals to 6? So 52 plus 12 is what? 64. The square root of 64 is 8. 8 minus 2 is 6. So it's giving us the correct answer. What about minus 12? So if we put the minus 12, minus 26 multiplied by minus 12 plus 12 minus 12 there, is it giving us 6? So 26 multiplied by 12, what do you get? What do you get? 312 plus 12 is giving us 324. The square root of 324 is equals to 18. 18 minus 12, is it equals to 6? So it is equals to 6. So that means that two of them, which is minus 2 and minus 12, satisfies the above equation. So minus 2. So actually, you can be given a question like this. This is actually covering many sections. So it's covering the radical, how to solve the radical, and then coming down, deals now with the what? The AC method, how to solve the quadratic equations. How to solve the quadratic equation. Any question up to that? Okay, now solve square root of minus 11c plus 12 equals to minus c. Solve that one. Solve the value of c. So you will not dismiss this one so easily because there is a negative there. But the issue is that is a what? We don't know what that c is. So we don't actually know what c is. So we need to look for the value of c. So here, this is the same as minus 11c plus 12 raised to 1 over 2 equals to minus c. So to remove this square here, then minus 11c plus 12 equals to minus c1, minus c, and then this square. So in this case, minus 11c plus 12 equals to what? C squared, equals to c squared. So you take all these values to the other side, so square plus 11c minus 12 equals to 0. So the product is minus 12 and the sum is 11. What are the two numbers? So 12 and 1, minus 1. So c squared plus 12c minus c minus 12 equals to 0. So c plus 12 minus 1, c plus 12 equals to 0. Using the zero product property, c minus 1, c plus 12 equals to 0. So our c equals to
1, and our C equals to minus 12. So which one among the two of these can you take for the value of C? Without even solving it, proving it. 12. You take minus what? Minus 12. So you take this minus 12. Because if you take this minus 12 here to be C, then that means this one becomes what? Positive. And since this one is the square root and it is even, then we are able to get the positive value there. But you cannot take C to be 1 since it will be negative there. So it will not satisfy this. So that is how you can prove. So you take C to be equals to 12 to be the solution of the value of C. So this will not satisfy. Any question? We still have 2 minutes. So another one, like the similar one, is minus 41z plus 10 plus z equals to 10. So what you do, you take z to the other side, and then you square it, and then you get the solution. So actually, this again will take you to how to solve the quadratic equation. Any question? So that is section 8.6. So when we meet, we'll do section 8.7 and then also section 9.1. Okay, so make sure you do your homeworks. Finish your homeworks. If you have any issue, you can always email.